I don't use them as much. Yep.
We should start only using them.
Okay. Lesson 66. Use substitution, change of variable. If you look at the sideboard where the objectives are, notice it says to use substitution when guessing would be difficult. So this is more, we're integrating again. We've done, 2 lessons on integration by guessing, if I recall? Because we had the initial where everything always magically worked out perfectly, right? And then we had the next one where things still worked out pretty well, except it was off by a constant or something, right? And so we'd have to, if it was off by 5, we'd have to put a 1/5 in or whatever the case was. Okay, so now it's still kind of guessing. And it's still similar how I've been kind of showing you. I've kind of showed you use substitution in a way because I've kind of showed, okay, use this as your guess, take the derivative. Similar there. Okay, so let's see what we can do with it. Example 1, we are being asked to integrate the integral of 40x times x to the second minus 4 raised to the 5th dx. Let's see, I'm trying to decide how I want to ask this here. My brain's having to think. Okay. If we did this like we would do in the past, okay, what would you think about with this problem?
X squared minus 4 to the 6.
Okay. Yeah, because we see x squared minus 4 to the 5th as the main piece of this problem, then we would guess that the integral would be that same item to the 6th, right? Okay, so with use substitution, what we're going to look at is, okay, so what is that inside piece there? And that inside piece is x squared minus 4. So I'm going to talk about use substitution, I'm going to use u as x squared minus 4. Okay? And I picked this because this was the inside piece. Basically, the inside piece is going to mess everything up with chain rule, right? Now, while we're here, let's go ahead and take the derivative of that. The derivative of u, I usually list as du. Okay? Derivative of u is 1 with respect, so just du. Derivative of x squared minus 4. 2x times dx. Okay, and we're going to use this as part of our use substitution here, which is why I wanted to go ahead and find our derivative. So first thing I did is I let u represent whatever my inside piece was. I took that derivative. So that means x squared minus 4 is u. I'm going to replace it. And I'm going to try and get this all in terms of u. So x squared minus 4 is u. So I'm going to write this as u to the 5th. Yes? Now, what do you notice about matching pieces over here? When we look over here at du is equal to 2x dx, right? Notice what is here for sure. There's an x and a dx, yes? X and dx. Over here there is an x and a dx. And there's a couple different ways we could do this. But I'm going to go ahead, let's go ahead and get x dx by itself, which means what do you do with that 2? You divide it over and put it with the du. And again, there's a couple of different ways we can do this. But if I divide it over, du over 2 is equal to x dx, which means x dx here in my problem can be replaced with, what is it equal to? Du over 2. So I'm going to replace it with du over 2. And then what's the other piece here that we didn't get taken care of? The 40, but that 40 is just a constant, which really means that 40 can just come out front. Have I accounted for all of the pieces of this problem? 40 is out front. X and dx are rewritten with du over 2. And x squared minus 4 to the 5th is rewritten as u to the 5th. And so what I've done is I've changed this to a problem in terms of u. Now, the 2, probably the easiest thing to do with the 2 is also a constant. Where can I take that 2 then? Out front. And so I'm out front, I can have, I'm going to write it as 40 over 2 for this step. If you want to go ahead and write 20, that's fine, because it's going to become that very quickly, yes? So it's pulling that denominator of 2 out front, it's 40 over 2, and then we're doing what? The integral of u to the 5th du. Pretty easy integral to do, if we're having a good day and get all of our numbers right. Okay, so 40 divided by 2, I'm just going to write out front as 20. What is the integral of u to the 5th?
160.
Add a power when we're integrating and divide by that new power. So 1/6 u to the 6th, and officially we should say plus c. Now, why am I going to say I'm not quite done? Partially, we can simplify the 20 and the 1/6, and yeah, unsubstitute if you want, okay, or resubstitute. In other words, we start the problem in x, we need to give an answer in x. Okay, so there is a 20 and the 1/6, which you can, what's 20 and 1/6 going to become? 10/3. I probably should have done that there, but I'll do it next one. U, what was u? So I'm going to put my x squared minus 4 back in there. So x squared minus 4 raised to the 6th plus c. And as I said, I don't know why I didn't, but the cleanup I should have done. 20 times 1/6 can become 10/3. X squared minus 4 to the 6th plus c. Okay, what do you think? I like to think of it as it's kind of a variation of what we've already done. Okay, instead of guessing and trying to see if all the pieces work out, we're just picking a piece to be u and then getting it all to work out. Okay, on this particular problem, would some of you guys still been okay with guessing possibly? It's very possible. Okay, it's not an exceptionally difficult problem to where you couldn't have. It's one of those things where you want to have the tool in your tool belt, so to speak. Okay, you want to make sure you know how to use this idea for complex problems, especially. Okay, guys, shall we look at B? Sorry, example 2. Huh? Doesn't it look so fun, though? It does look so fun. Okay, the integral of 20 cosine of ax dx over the square root of b plus sine ax, where a and b are constants. So those are just numbers. They're just going to make life difficult, but guess what? You're going to see lots of things like a and b on AP. They're not going to always give you numbers. So, okay. Thoughts of what we want to use as our insides for u substitution. Because remember, u substitution, we're no longer thinking, okay, we are kind of thinking what's the main thing, but we don't have to guess, okay, what's going to be the integral. We're thinking, okay, what's that inside that I can use for u substitution? Okay, because what do you guys see? You see a square root in the denominator, yes? So that square root in the denominator is going to be something to the negative 1/2. So if we had to guess, our answers are going to be something to the positive 1/2. Okay, but what we're going to do is we're going to take what that inside is, we're going to make that our u. So I'm going to say u is b plus sine of ax. Okay? While we're here, go ahead and take the derivative. What's the derivative of u? Du. Derivative of b. 0, because remember b is a constant. Derivative of sine of ax. Okay, and so what I was going to say, derivative of sine of something is cosine of something times the derivative of something. So ax is my something. What's the derivative of ax? A. So realize you're taking the derivative anytime it's something other than just an x inside. And then, of course, times dx. Now, start looking ahead. What's going to match up? Okay. Cos ax dx matches up with cos ax dx, yes? What's the part that's not going to match up? The a. So what I'm going to suggest is so that cos ax dx can be replaced, take this a and what did I do earlier? Divide it over. So if I divide my a over, it's du divided by a is going to be equal to cos of ax dx. Okay. So, let's set up this integral. This constant of 20 on top can go where? Outside the integral. Okay? What do you know about the square root of b plus sine ax? Okay, b plus sine ax is u. Square root in the denominator is u to the negative 1/2. So I'm going to do u to the negative 1/2 times, so 20 is taken care of. My square root in the denominator is taken care of. What have I not replaced yet? Yeah. Cosine ax dx. What was cosine ax dx equivalent to? Du over a. Now, keep in mind, a is a constant. What can I do with that a? Take it out front. Okay, so just kind of clean up everything. And so I'm going to have 20 over a times the integral of u to the negative 1/2 du. And now we're to the point of basic integration. Still 20 over a. What's the integral of u to the negative 1/2? You can think that way. Okay. If you add 1, I'm going to write it differently for the moment. It's u to the positive 1/2, right? And then what do we officially do? We divide by that new power of 1/2. So for a brief moment, I wrote it as u to the 1/2 divided by 1/2. However, exactly, we're not going to leave it like that. Dividing by 1/2 is multiplying by 2. So I can take that 2 and put it with the 20. So 40 over a times u to the 1/2. What do I need to write in before I go any farther? Plus c. I made this 40 over a because I was taking the 2 from there. So it depends where you put your 2. Okay, what's my final step? Yeah, substitute the u value back in, right? Sorry. 40 over A.
It's not your fault. I'll blame you.
It's just, I know, it's annoying.
Get it?
U is B plus
So funny.
sine of AX. And I started writing this, so I'm just going to finish it this way. Raised to the 1/2 plus C. If you wanted to, you could also put it as a square root in there with 40 over A out front. Yeah, my husband made the comment yesterday. He's like, man, I might have to work a full week this week. And it didn't even occur to me, because he's like, I haven't worked a full week the last 2 weeks. And it didn't even occur to me that I'm the same way. I haven't worked a full week the last 2 weeks because I've had 3 subs in the past 2 weeks, which for some people may be normal. It's not normal for me. I hate having that many subs, because it also means recording a lot of outside videos. Okay. Ready?
At least at the start of the week, you only had to record one for us because there were classes we were doing
Yeah.
for you.
Between the 3 days I missed, I recorded, 7 videos? So, but it's still, if you think about it, it's normally, so I recorded, if I missed, it's like Friday, everybody had a video. So I recorded 3 videos. But normally here I would have been teaching 6 different times. So instead I sat home and graded tests. Okay, example 3. Keep us moving. We've got lots to do today. Okay, thoughts on what you want U to be? The insides of the main thing. So if the main piece is my radical, the insides of that is the U, x minus 1. So we're going to try U equals x minus 1. Take the derivative while we're here. Derivative of U is du. Derivative of x minus 1, just 1 dx, so dx. Okay. So, let's see. What am I going to say about the 7?
Get it out, sign it.
Okay, I'm going to say move the 7 out front of the integral. What about the square root of x minus 1? Square root of u, or I'm going to write it as u to the 1/2. What about dx? It's du. What's not accounted for? The x. Normally that x is accounted for at this point, isn't it? Normally it's part of my du part over there that I can finagle around. Okay. Well, here's the deal, guys. We can't work this as is. We can't work it with u's and x's. We need one or the other. So we need to figure out a way that x can be written in terms of u.
Until we solve the topic equation for x.
Yeah, we have, and that's exactly what we need to do. We have a connection between u and x, right? We created a connection between u and x when we suggested, okay, we're going to go with u equals x minus 1. You can move this around and it still be equal, right? If u equals x minus 1, what does x equal? Add 1 to the other side and u equals x plus 1. Can I substitute that value in for x? Yes. And so here, x is going to be u plus 1. This is an example of a problem where you couldn't do integration by guessing, because we'd be stuck with that extra x there. This is where the u substitution becomes a necessity, because you need a way to deal with that extra x. Okay, what has to happen before we can integrate? It's a factor of u plus 1 times a u to the 1/2. So as not fun as it looks, we are taking that u to the 1/2 and we are distributing it inside the parentheses. So 7 stays out front of my integral. u to the 1/2 times u to the first. U to the 3/2. Because 1 plus a half is 1 1/2 or 3/2. Plus u to the 1/2 times 1. U to the 1/2. All times du. Can I integrate now? Add 1 to the power, divide by that new power, right? So I'm going to keep my 7 out front. What about u to the 3/2? Yep, 2/5 u to the 5/2. You add 1, it becomes 5/2. Dividing by 5/2 is multiplying by 2/5. Plus, what about u to the 1/2? 2/3 u to the 3/2, and don't forget, plus c. There's lots of different ways you can leave your answer here. It does look like in my answer key I've distributed the 7. I don't know if I'm necessarily saying you'd have to, but I distributed the 7 and then also then plugged in my u value back. So 7 times 2/5. So I have 14/5 u to the 5/2 plus 14/3 u to the 3/2 plus c. If I replace u, what was u? X minus 1. So 14/5 x minus 1 to the 5/2 plus 14/3 x minus 1 to the 3/2, and don't forget, plus c. Okay. Ready to try the bottom part? Difference between the top part and the bottom part. The bottom part is definite integrals. We have to evaluate these when we get done. And when we go to evaluate these, there's 2 different ways you can do it. Well, let's plan for this to be a non-calculator problem. Okay? I agree, calculator is an option. But even with the calculator, though, you still have to talk about how we're going to put it into the calculator. Well, I guess you're saying that if you just put it in from the beginning. Right. Okay, so we have to have a technique, though, when they throw this on the non-calculator portion of the AP test, how to deal with it. Because they're not going to put something like this on the calculator portion. Are you kidding me? Sorry to burst the bubble there, but
They could do it. It's like 8.
Okay. Okay, so change the variable to evaluate the integral from 0 to 1 of x sine of pi x squared dx. Okay, let's start the same way we have been. What's u going to be? What's my inside? Sine is the whole item, so then we're going to be integrating sine of u. And so u is pi x squared. Go ahead and take the derivative. Derivative of u is du. Derivative of pi x squared. 2 pi x dx. Okay, so let's start looking around over here. Pi x squared is going to be my u, yes? We're also going to have x and dx. X and dx are going to be covered by the du, yes? What's the part that's not covered? The 2 pi, so what have I been doing with the 2 pi? Dividing it over. So du over 2 pi is x dx. Okay, so as I work to write out my integral here, sine of pi x squared becomes sine of u. X dx is going to be replaced with du over 2 pi. Okay. Now, our original problem was in terms of x. Yes? All my variables were x's. My problem was in terms of x's. So what does this mean about this 0 and 1 here? They are what type of values? They are x's. They were given to you on a problem with x's. They were x's. What is my problem now? My problem is in terms of u. Okay, so we have 2 options here. Here's the deal. We cannot work this problem in terms of u and then plug in 0 and 1 into our u problem. Okay? One option, which is doable, but I'm not going to encourage it, would be to go ahead and work this problem in terms of u. When you get done working in terms of u, plug in, here's the catch, that's the hard part. You have to remember then to replace u with pi x squared, and then you can use your 0 and 1 values. That is one option. Now, the option I'm going to focus on, and there's nothing wrong with that option. The only catch is you can't forget to replace the u before you put your numbers in. The other option is that instead of using 0 and 1 as x values, we can change those x values to u values. And I find that a little bit easier if we change them now while it's all in my head that, okay, I'm changing variables, and then I don't have to worry about changing anything later. Meaning, right over here, we defined u to equal pi x squared, correct? So, what's going to happen when x is 1? U is going to be pi times 1 squared, which is pi. So, instead of having 1 as my upper boundary, what's my upper boundary now? Pi. Does that make sense what I'm doing? And then my other boundary was x equals 0. So what do I do with that x equals 0? It's going to be pi times 0 squared, because it's u times pi x squared. Pi times 0 squared is 0. So my boundaries now became, that bottom boundary went from 0 to 0. So the bottom boundary actually stayed. Now what we can do is we can integrate. We can work this, finish this problem using 0 and pi instead. The only reason I encourage this is because now I'm not going to have to remember at the end, after I'm done working everything, to go back and change my boundaries. Okay? Let's see. Before I integrate, what should I do with that 2 pi in the denominator? Yeah. The du divided by 2 pi, I'm going to bring this 2 pi out front and say 1 over 2 pi times the integral from 0 to pi of sine u du. What is the integral of sine? Okay, so the integral of sine is negative cosine. So this is going to be negative cosine of u evaluated between 0 and pi. And don't forget it's 1 over 2 pi out front. So 1 over 2 pi stays 1 over 2 pi. Negative cosine of u, what do I do here? Yeah. It's going to be negative cosine of pi minus negative cosine of 0. Minus negative, so I'm going to say plus. What's cosine of 0? 1. 1 plus 1 is, and that number times 1 over 2 pi? Yeah, it's 2 over 2 pi, which does become 1 over pi is how I'm going to express my answer. I don't know what craziness you guys have out there, but you have whatever craziness you want out there.
You ever make a joke if you're in the Roman numerals, but then the Roman numerals ignore the same exact thing? Look at algebra.
Someone this morning did talk about doing all their algebra and Roman numerals. I thought, no, thank you.
Get numbers 100.
Okay. Now, if you didn't like having to change your variables at the beginning, you could work the whole problem. You would have gotten here to negative cosine u, and before plugging in 0 and 1 instead, you would have had to say, okay, it's negative cosine of pi x squared, and then plug in 0 and 1 to that. It works. There's nothing wrong with it. It's just a matter, I think this is the more preferred, just you don't have to remember when you get to the end to go back and substitute anything in. Okay? One more. Ooh, fun stuff. What's the big function here? Okay, e to that power, yes? Okay, so what do I need u for? That power, right? That sounds bad. What do I need u for? But it's that power, right? Because what we want to integrate is that e to some power. So we're going to use u to be sine of 5x. Check your derivative out. Derivative of u, du is, what's the derivative of sine of 5x? Okay. Derivative of sine of something is cosine of something times the derivative of something. Derivative of 5x is 5 times dx. If you went ahead and said 5 cosine 5x, Daryl, I know you probably did, that's fine, of course. Okay, that would have been a problem. Okay, what matches up here, guys? Cosine 5x dx? The part that doesn't match up is the 5. So there's your 1/5 we're going to have. So du over 5 is going to be cosine of 5x dx. Okay. So let's rewrite our integral. E to sine 5x is going to be written as e to the u. Cosine 5x dx is going to be replaced with du over 5. What about my boundaries? Do I keep them as 0 and pi? You need to officially change them. Okay. So right now they're x values. We're going to change them to u values. So if we change pi to sine of 5x, so the sine of 5 pi. Okay, guys. Sine of 5 pi is equivalent to the sine of what? 5 pi is odd, and all of your odds are the same. Right? If you subtract off 2 pi, you get down to 3 pi. Subtract off another 2 pi, you're down to 1 pi. So what's the sine of 1 pi? 0. So sine of 5 pi is 0. Okay? And we're going to repeat this process with 0. Sine of 5 times 0. Well, 5 times 0 is 0. What's the sine of 0? 0. So what are my new boundaries? 0 and 0. Well, okay, so officially, if I rewrite this neatly, not that you'd have to because we're pretty much done at this point, this 5 out here can go out front and we can say it's 1/5 times the integral from 0 to 0 of e to the u du. You can integrate all you want, but here's the deal. When the boundaries are the same, that was one of our properties. When your upper and lower boundaries are the same, what does your integral always equal? 0. Because think about it. If I integrate this, and then I'm going to plug in my two boundaries, right? We plug in the upper boundary, and then we're going to subtract, and we're going to plug in the lower boundary, right? If upper boundary and lower boundary are the same, you're getting the same results. Upper result minus the lower result, which is the same, is going to equal 0. Now, if you don't believe me, work it out. But you have every right, without any work, to say this is 0. Reasoning being, when upper and lower limits are equal, the integral equals 0. And I'm going to write that. When upper and lower, you can say limits or boundaries, are equal, the integral equals 0. And the good time to remember that is when you end up with an ugly integral. You know, I'm like, this is an excellent multiple choice question here. Is they'll give you some ugly integral, and then the boundaries are identical. And you're sitting there stressing, trying to figure it out, but yet it's 0. Okay? So, good one to know.
I wish I wanted the integral or like that.
Oh, don't we all?